Hey, Vlad here, devinsideU.com. Welcome to another video. In the previous video, we have faced a few challenges implementing filter, but today we're doing something else entirely. The biggest question that people seem to have about streams is how to put data into them. And so today we'll see multiple ways of generating streams. Let's get started. As always, we're in the Ubuntu virtual machine, which is fully maximized, and we're using Sublime Text, which is the editor of my choosing, which is also fully maximized. And we're using a wonderful plugin called Terminus, which emulates the entire terminal for us, which we use to run SBT, which we use to rerun the test every time we save the file. Before we even begin today, I want to make a tiny refactoring. For some reason, I kept calling previous events. For some reason, I call them previous events, but clearly they actually follow. So what I'm going to do is I'm going to mark all of them. In fact, I'm going to mark it like that. Okay, so previous events, I'm going to rename it to following events like this. And I'm also going to search for previous, or maybe previous like this. Okay, so in this case, I'm also going to say following. I'm going to save that, and I'm going to go to timeline suite. Do the same thing over there. Let's search for previous. Yeah, there we go. Previous should be following, and maybe capital previous. No, that's all good. Let's see if we need to go to playground. Playground, previous gets commented out, but still it's going to be following like that. We don't need the playground. All right, it looks like everything is green. Cool. Okay, so let's begin with the actual content. So the first thing that we're going to do is we're going to write a test that I'm going to call Gen. I'm going to call it Gen1, and we're going to create a new environment over there. And what I'm going to do is I'm going to say def ascending. It's the same way that we have done before already. So I'm going to type it up anyway. So I'm just going to create a side effect over here with a seed, and I'm going to prepend it to recursive call of seed plus 1. And this way we can have our ints, which is just a timeline of ints, which is going to be ascending of seed equals 0. Let me scroll down a little bit. So now we can have 0, 1, 2, 3, which is a timeline of ints, and it's just ints take 4. Events occurred should be 0, and now we can put them all into a list like this: 0, 1, 2, 3 dot forced. Let me scroll down a little bit. So now events occurred should be 4, and list should be a list of 0, 1, 2, 3, and let's see, it should be green. Now, we have already seen this in the previous video, and this is probably the simplest way of streams, but in fact, it's not the most rudimentary kind of streams. The most rudimentary one is the one that generates the same thing all the time. So what I'm going to do is I'm going to copy the whole thing like this, and I'm going to paste it above. And in fact, I'm going to rename the lower one to Gen 2, and I'm just going to go to the top, and instead of saying ascending over here, I'm just going to use the same seed. And because I'm using the same seed, I'm going to rename this, and I'm going to call it same. And now because it's the same, this is not a 0, 1, 2, 3 anymore. This is just 4 zeros, right? And so the end result is going to be 0, 0, 0, 0. Like this. Now, for the super simple cases like this one, it is also typical to hard code the seed. So what we're going to do is I'm going to copy the whole thing, and I'm going to go even above, even more above, and I'm going to call it Gen 0. So now instead of having the seed over here, I'm just going to remove that, okay? And I'm just going to put a 0 in here and the 0 in here, right? But the 0 in here doesn't even need to be there because it's now just a tiny def without any parameters, okay? So now we can just call it zeros. This is just the zeros. Now we can actually remove the ints, and let's see, it should still be the same thing. This should obviously be zeros like that. Now, this is definitely the most rudimentary way of generating a stream, but you need to be careful whether you use a def here or a val. In fact, I'm going to copy this environment, I'm going to paste it below. It's still in Gen 0. So in one of them, I'm going to use a val, and in the other one, I'm going to use a def. So let's use a def in the second one, but let's use a val over here. Right, and let's see what's going to happen. Now, this test actually failed. If we scroll up, in fact, we're running the appropriate test. As unfortunately, I have to scroll up like really high. 1 was not equal to 4. So over here, where we're saying 4, it is actually like that. Right, let's see. Yeah, now it's green. Now, these were all the things that we have seen before, but now we're going to start with something new. So I'm going to collapse Gen 0, going to collapse Gen 1, and in Def 2, I'm actually going to take these two. Or in fact, I'm going to take the whole Gen 2. I'm going to take the whole Gen 2, and I'm going to paste it over here, and I'm going to call this Gen 3. And in Gen 3, what we're going to do is we're going to generalize this function over here. So what we're going to say is we're going to say it's not just going to be a seed. We're also going to have a function that will do this +1 basically. So it's going to be a function from int to int. And over here, instead of doing seed +1, we're just going to say next seed like this, right? And so the implementation over here where we say ints is just ascending, seed is 0, we also need to pass in the function over here where we're going to say, okay, the integer is going to come in and we're just going to do +1. Let's see. I forgot to pass it in over here, right? So we need to keep passing it like this. Now, because what we're doing with our seed is determined somewhere else, this is not ascending anymore, right? This could be something totally different, right? We can go to -1. So I'm just going to call this a generate. And also because this function can be even generalized even more, we don't even need to have ints over here, right? So we're just going to say, okay, this is some sort of event. So all these ints, they will just become events like this, but now it's not going to compile because it's just not capable of inferring the type, and we already know this trick. We're just going to make this function curried, and the compiler will be able to figure this out for us like this. So now it should work exactly the same as before. What's up? Oh yeah, it's the same thing. I forgot to remove it here, right? So now it's curried, so now I have to pass it like this. Now the next one is going to be even more interesting. So what I'm going to do is I'm going to copy the Gen 3, and I'm going to go down over here, and this is going to be Gen 4, and I'm going to go down and I'm going to press enter over here and over here. So what we're going to do is we're going to generate something, right? But then at the very end, before returning it, we're also going to transform it, right? So we're going to transform this to event. So we need also to make sure that we have an event over here. Okay, so all we need to do is we need to transform the seed like that, and we need to not forget to pass it along over here, transform. And now over here we also need to explain how to transform this integers into something else. Now in this case we don't want to transform it into anything else, so we can just take it and return it back like this. Let's see if I made any typos. I did. It's not transform, it's transform like this. Okay, now this is the identity function, so we can just go over here and say identity like this, and we get a compilation error because in our math library from the video about monoids, if you have skipped it, don't worry, we're not going to talk about them today. We called one of the laws identity, so we're going to go in there now and rename it. So let's go to math library package object, and we have identity somewhere here. So see, exactly for the same reason we were using predef.identity over here. So in fact, I don't want to do this, right? Instead, I want to just be able to say identity, and therefore I'm just going to rename this one to identity law. Now a few other things, and I'm going to compile now. So one thing in group theory like this, line 35, we don't use identity here, we use identity law like that. And it looks like this is everything that we needed to change. Let's also run all the tests real quick just in case, but this should be actually enough. Yeah, it's enough. Let's go back to running only on the timeline suite, and I'll collapse the groups here. I'm going to close it. I'm going to close the package. So now we're back to our timeline suite. I'm also going to show you an example where we actually use transform for something interesting. So I'm going to have a Gen 5 over here, and what we're going to have is we're going to have a tiny case class over here. I'm going to call it bank account, for example, bank account, and it's going to have a balance, which is just an integer. Okay, so in this case what we're going to do is we're not going to have timelines of ints, we're going to have timelines of bank accounts, bank account, right? So over here, instead of identity, we're going to pass in bank account, right? And over here it's not going to be just a list of integers, it's going to be a list of bank accounts like this. Let's see if I've forgotten something, but I don't think that I have. Yeah, it's all green, it's all good. The last iteration, or the last iteration that is known to me, is going to be to explain to our generator that it should be finite, that it should stop at some point. So we're going to go over here, and this is going to be Gen 6 like that. Okay, let's see, it should compile it real quick and it should be green. All right, so what we can do here is we can press a comma here and we can say it should finish. It's going to be a function that is going to take the gen and return a boolean. Okay, so what we'll do in here, we'll just say, okay, if should finish was a seed, okay, then we're just going to do timeline.end, and otherwise we're going to do the same thing as we were doing before. We just need to not to forget to pass it along over here. Should finish like this. And now over here where we're generating the bank accounts, we can say, well, just keep generating them forever, right? So just whatever bank account you pass in over here as a seed, just always return false, and therefore should finish is going to be false, and therefore it's never going to be over here. Okay, let's see if I made any typos. It looks like I didn't. Sublime keeps unfolding everything for me, so it just jumps from here to here because it unfolded Gen 4. Maybe I should stop folding things together. Okay, so we're in Gen 6. We have the should finish, which we're calling over here, passing it along over here, and it never finishes. So the next thing that we're going to do is we're actually going to have an example where it will finish. So I'm going to copy, you know what, I'm going to copy the environment, not the whole Gen 6. So I'm just going to go over here. And I'm going to say over here that instead of false, I'm just going to say the gen that you're passing in, as soon as it's 4, then you should stop, like this, right? So let's see. Take 4 is 4. So now what we can do is we can remove that, and it should still be green. What did it do? It did it. Oh, I collapsed the previous environment again. I'm sorry, guys. All right, so with take 4 or without take 4, it's still green. Okay, like this and like that. Okay, there we go. There we go. Now this is as far as it goes, and this function is called unfold, which is a dual to fold. Now fold is a canonical representative of a recursive function. It starts with a full collection and then just collapses it down, you know, typical divide and conquer, until it reaches the seed. Now unfold, on the other hand, is the canonical representative of a co-recursive function. Co-recursive functions, they start with some base case, the seed, and then they just keep growing. They keep producing more and more data, and whatever they produce, they feed back into themselves and keep growing like this. By the way, this co-prefix is very typical for duals. You know, you have domain and codomain, recursion, co-recursion, routine, coroutine, and so on. I have no idea where this all started, but I blame the Greeks. Just kidding. Or am I? And yet another, by the way, is that there's an entire programming style based on folding and unfolding called origami, because folding and unfolding. You get it. But we're not actually going to see proper examples of the origami style. All right, so I'm going to go ahead and rename it to canonical unfold, and I'm going to call it canonical unfold simply because there's also another way to express it, canonical unfold, and I'm going to name this other way simply unfold. Okay, so we're actually going to go into Gen 5 over here, and we're going to create another environment. So I'm going to copy that. I'm going to unfold it again, or uncollapse, whatever. So I'm going to paste this in over here. So we're going to change this generated function. So now it's going to basically fuse the next and the transform into one, right? So I'm going to call it next over here. So it's going to take the gen and it's going to produce both the event and the gen, like this. And by the way, if you look very, very closely, then this function looks exactly like the state monad. So let's implement it real quick. So we're going to do this, and we're going to go over here, and we're just going to get out the transform seed, which is basically this transform seed. It's transform seed. It's going to be over here, and we're going to have next gen, which is going to come from here, next seed. Okay, so both of these are just going to come from next seed, because I just called the function also next. You know, I just kept calling next. I have no idea how to properly call it, right? And so now over here, we're just going to take that, put it over here. It's going to take that, put it over here, and we're already done, except for the fact that we're actually creating the ints over here. So what we need to do over here is we need to, I'm going to duplicate that. I'm going to comment this one out just so that you have an example. So I'm going to say, okay, some number comes in, and then a bank account comes out with this number, and also the next thing comes in. And we had really functions that look like this in the monad series where we talked about the state monad. Okay, so I can throw this out now, and let's see if I made any typos. Oh yeah, over here I just need to pass in next like this. I believe that's all I wanted to change. So now I'm going to copy that and I'm going to unfold it again. So now I'm going to go to Gen 6, in which we have an example where it actually finishes. So we have an environment here, and let's put it over here. Okay, so in this version of, by the way, I kept calling it generate. I should call it unfold like this. Unfold, and in the previous one as well. Where is it? Not this one. This one over here. Okay, so this is unfold like that. Let's see if it compiles. It should. Okay, so this is the one that I just pasted. Okay, so the next iteration is going to be to explain it when it should finish, and we do this by basically just wrapping this thing into an option. Okay, so now over here we need to pass the seed into next, and then we're going to match on that. And if it's a none, then we're going to do timeline dot end, and if it's a sum, and it's going to be a sum with exactly this, with exactly that thing over here, right? So now we can just remove this and move this over here, and I forgot the arrow like that. Okay, so now if you want this function to never to finish, which I'm not going to show you because it's basically simple. So if you never want it to finish, you just put a sum over here. I just said that I'm not going to show you, and now I'm showing it to you. Interesting. Okay, we don't need this empty line, by the way. Okay, so this function basically never finishes. And another one that we're going to do, I'm not going to use this one. So hold on, I'm going to comment this out. I'm going to throw this out like this. I'm going to say, okay, a number comes in. And if the number is 4, then please stop. Otherwise, we're going to have the same thing as over here, right? Like that. Okay, so this is the typical example. Usually this is how you see unfold in the wild, especially in the Scala world where we have, options. Now there's just one thing that we have forgotten. So if I take this environment, I'm gonna copy that, and what do we have here? We have Gen 6. So I'm gonna have Gen 7. I'm going to paste that in over here, right? I'm going to scroll up, and what I'm going to do over here is we don't need the bank account over here, so we're just going to generate ints like that, and we're just going to keep going. So I'm going to say n comes in, some n comes out with the next gen, which is n plus 1. Okay, so what I'm going to do here is I'm going to remove the side effect from here. So I'm going to remove the side effect from there. I'm going to cut it out. And I'm actually going to put it into the seed. Right? And then this should be 0. And yeah, the rest should be fine. Let's see what's going to happen. Okay, first of all, it still says bank account. I don't need the bank account. I need int. And I don't need that. There we go. All right, what have I forgotten? Sum int option. Oh, the whole thing needs to be in a sum. Hold up. Like that. Like that. There we go. Okay, so now 2 tests fail, and they fail because we have forgotten to make the seed. So this is a 1 now. We've forgotten to make the seed a banana parameter. So what we're going to do is we're going to ignore this test for now. Ignore it. Or in fact, let's not ignore this. Let's go to test like this, and let's go and make gen simply a banana parameter, and let's see if that fixes our issues. And it doesn't. So what we're going to do now is we're going to ignore this for a while. I'm going to ignore this for a while, and we're going to go up and start from the bottom and see where exactly all of this goes wrong. All right, so now in Gen 0, there is no way to remove this because otherwise I wouldn't be able to insert it anywhere else because the seed is hard-coded. Okay, in Gen 0 it has 2 environments, and the second one we also can't do anything. In Gen 1 we can't, so we can go over here, we can say that it's a banana parameter, that this is going to be the seed, and this is going to be the side effect. Oh, come on, side effect of 0, like this. Let's see. Okay, it looks like it's still green. Okay, so Gen 2. So we're going to make this a banana parameter, and we're going to remove the side effect from here, like that. Let's not forget to put the side effect over here, like this. Let's see. Let's scroll down. Okay, so this generate. Let's go over here like this. Cut that out just leave the seed alone like this, put it in here, side effect of 0, not 9, gen 3. All right, so now let's go to gen 4. Let's have a seed as a name parameter over here. Let's remove the side effect from there. Let's do that, paste it over here, like this, like that. All right, let's see. Still green. Okay, so the 5 is over here, gen. Let's remove the side effect. Let's remove that. Let's go over here, paste it in, 0. Let's see. Still green. All right, the next one is this. Let's do that. Let's remove the side effect from here, get it out, like that. Put it over here. Let's see. All right. Oh, okay, so now it's red. So this is where it'll start it. Now let's look at the error message. So the error message says 1 was not equal to 0, so it's over here. Okay, so the problem here is that we're evaluating these things too early. Okay, so if you put a lazy val over here, let's go down. Okay, it's still red. Let's look at the error message. Now it says 1 was not equal to 4. So in the previous example, we were evaluating the seed too early, and over here we're not evaluating it enough times. So instead of this whole thing, we're just going to go and we're using transform seed, and we're just going to call next seed over here, right? And we're just going to get the first element out of it, and over here, over here, where we use the next gen, we're just going to paste it in again, and we're going to take the second thing out. Okay, so now we're not using this, so now we can just do that. Now let's see if that helped. Let's scroll down, and it looks like it did. Awesome. All right, let's keep going. All right, so we have our gen 6, so we're going to have the seed over here, and we're going to remove the side effect from here, like this, like that. And we're going to put it over here, side effect, like that, like that. Let's see what's going to happen. And it's red yet again. So let's scroll up. Same thing, 1 was not equal to 0. Now, we had this issue actually with filter, because in this case, if you look at filter, actually, hold on. So I'm going to go to timeline. I'm going to look at filter for data. It looks pretty much the same, right? So it has to make the decision right away whether it will go here or it will go here. So it needs to touch the current. And the same thing is happening over here. It has to work with the seed right away to figure out whether it needs to end or whether it needs to continue. Now, in just a few minutes, we're going to start moving these unfolds into the companion object of timeline. And so when we arrive at that point, we will do the same trick as we did with filter, right? We're just going to move it to data, wrap it into a timeline. Until then, what we're going to do is we're going to just comment out this line, and what we're going to do is we're going to reset the events counter like this. Now let's see what's going to happen. Let's scroll down a little bit. All right, let's see the error message. Now it says 8 was not equal to 4. All right, that's interesting. So it looks like we need to cache something. All right, so what we're going to do is we're going to go over here. I'm going to put the whole thing into curly braces, and I'm going to go over here, and I'm just going to memorize the seed. Memoized seed, right? Because it's a name parameter. Okay, so I'm just going to do that. And now everywhere where we use seed, which should be in 3 places, I'm going to use memoized seed, which is here, here, and here. All right, let's look down, and it's still red. Let's see. 0 was not equal to 4. Let's go and try and make it a lazy val. Gonna make it a lazy val. Scroll down. It's still red. 0 was not equal to 4. Maybe we memoized too much. So first of all, let's revert to lazy, and let's remove it from here. Let's not use the memoized seed over here. Let's use the actual seed over here. Let's see. Oh, now it's green. I guess we got lucky. Now we have a 4 over here, but let's not forget that this is actually a 5 because we're just resetting this events counter. Okay, so let's instead not reset the events counter. Let's just comment this out. I'm sorry, let's throw this out and put a 5 over here. Okay, so now it's still going to be green, but if I comment this out, and then it's going to become red, which I'm not going to do now because you know, in fact I'm going to do it. So let's do this real quick. So now it's going to be red because of this one line, but we're going to fix this one line later once we actually move the unfolds into the companion object of the timeline. All right, let's keep going. Over here we have our seed. It's the same thing. Basically, it's exactly the same thing. Okay, so let's do that, and let's go down over here, and let's do that. So over here we're going to have a it's not a lazy val, it's a val memo seed equals seed. So we're going to use it over here and over here. Okay, but not over there. Okay, so we need to do the same thing over here. We need to comment this out and we need to change this to 5 like that. All right, it's red. Why is it red? 4 was not equal to 5. Ah, yes, I'm stupid. The only difference is that, let's revert the lazy val, that I actually forgot to remove the side effect from here. Man, I'm telling you, implementing streams is so annoying. There we go, like this. All right, so that actually fixed the issue. Let's keep going. This one. All right, so we are still wanted to make it a by name parameter. And we're going to fix the implementation in just a bit, but I just don't want to forget this side effect thing. So I'm going to put it over there now. Remove this, and now it should be red. And in this case, what we need to do is we don't need to use next gen over here. So if I scroll up, it's going to say 1 was not equal to 0, which means we need to go over here and do next seed again. We need to call it again. We need to call it again, and we need to get it out, and we need to do _2. Let's see if that's fixed the issue. Probably not actually, because we still have the same thing over here. We need to comment this out, and we need to change this to a 5 like that. Now it should be green. All right, cool. So now we can take one of these. Let's take this one, and let's go into timeline. Let's go into the object data. And let's see, so we have this and that, and we have these guys, and we have all the applies, and now we're at the very end, which is over here probably. All right, let's put it over there. Final def unfold, and it doesn't produce a timeline, it produces data like this. All right, there we go. And let's go and copy the other one, which is this one, the canonical unfold. Let's paste it in over here. So it's going to be a final def canonical unfold, produces data over here like this. Okay, so what we're going to do now is I'm going to copy that, and I'm going to paste it over here real quick. And I'm also going to copy that, going to paste it over here. So I'm going to cut this out, both of them, okay? And I'm going to go to the object timeline and scroll down a little bit. Now we have all the factories, okay? This is the last one of them, okay? So now I'm going to just insert them over here. Press enter over here because these are the different ones. Let me do some indentation myself. So now it's not going to be data, it's going to be timeline like this, and the implementation is going to be very, very simple. We're just going to go over here and over here, going to press enter. It's just going to be a timeline with IO pure of data dot, okay, I'm going to do unfold seed comma, not comma, seed comma next, and in this one it's going to be canonical unfold, and it's going to be next, it's going to be transform, and it's going to be should finish. Okay, so now we can go to our tests and we can start using them. So we're going to go over here, and let's see. So I'm going to throw this one out, this canonical unfold, like that, and we can just use it over here, timeline. dot canonical unfold, and now it should behave exactly the same. Oh no, so now it has one less, so we need to go to 4. Right, this is exactly what we just fixed, right? Because we wrapped it the same way as we did was filter. Let's see if this one is now green, right? Because this is the filter thing. This should be fixed now. All right, let's go down and let's remove that one. All right, so that's just timeline dot unfold, and let's see, we don't need that anymore, and we have a 4 over here. Let's keep going. Oh yeah, Gen 7. We forgot about Gen 7. So let's just throw it out and just say timeline dot unfold. It already says unfold like this. And I believe for the first time it's going to be actually green now, right? If we actually test it. Let's see. Yes, it is. All right, let's see what else we can improve. Okay, this one's still commented out. It should be a 4. Over here it's going to be timeline dot. Now we don't need this canonical unfold like this. And there we go, it's green. Let's keep going. And okay, so this unfold has a different signature, so we need to have a few helpers to improve this one. Before we do that, there's actually a tiny bug. So if you go down over here, this one is fine, but over here where we're stopping the iteration, if we remove take 4, I believe that there should be a bug. If we remove take 4, it's going to fail. Yes, it fails. And it fails for the same issue that it failed when we implemented take, because it went one step too far, right? It should be the same thing. If you're taking 4 and if you're stopping at 4, then the result should be the same. So what we need to do is we need to go to timeline at the very bottom where we have our hold on, which one are we using here? We're using the canonical unfold. So in the canonical unfold, what we need to do is we need to add yet another else if over here, right? Else if. And I'm going to jump to take real quick because we did exactly the same thing in take. Remember, we had the take like this, and then at the very end, we added also this else if, but we realized that there's no point to run yet another iteration just so that we can return the next ACC. And it's exactly the same trick that we're doing over here. So we're going to say, otherwise, if should finish with the next of memoirs seed, well, then we can just do the same thing as we're doing over here, right? But we're going to stop, right? Data dot end. So it's basically the combination of this and of that, okay? And I believe that this should be also a lazy val. Let's go down. It's still red. I believe it should be a lazy val like this. Okay, memoirs seed. Hold up. Does it need to be a lazy val? Hold on, I'm going to remove that. I believe it should be a lazy val. Oh no, it shouldn't be. Okay, cool. It's just a val. Obviously, it shouldn't be because we're using it right away over here. Now let's do this to the other version. Where are we having this? Okay, so again, like this is the same thing. This or that. Okay, so in fact, I'm gonna leave it like this. Okay, so the other version is over here, canonical unfold. No, it's not this one. Where is it? We're still in Gen 6. This one stops at 4. So we need to remove the take 4, right? And it should fail again. Yes, it fails for the same reason, right? So if I scroll up, it says 5 was not equal to 4. So I'm going to go down and I'm going to go into a timeline over here. I'm going to go to unfold, and now we're going to fix it by doing the same trick. So now this next gen, we're not using it anywhere, but we actually will. So now I can do the same trick. I can say if next of next gen, if it's empty, then I'm going to do the same thing. I'm going to say transform seed and put into data end. Otherwise, do the thing, right? So basically, don't go too far, right? Like this transform seed. Okay, cool. Now we wanted to go to the other tests and to improve them a little bit as well over here. And then I said that for this guy, you know, there's no option over here, so we need a few helpers. But it turns out that there's actually yet another bug that we have here. I'm telling you, it cost me like a few days and actually nights to figure this one out and to reproduce it with a test. So I'm gonna go to Gen 7 and I'm gonna actually throw this one out. We're not gonna use it. Okay, so I'm going to write a totally new test, and for this one we're actually going to use the interleave function. Remember from the second video. So I'm going to have timeline1, which is a timeline of ints, and I'm going to use timeline dot canonical unfold with a side effect of 0. Okay, so now over here we're going to say, okay, the next function is going to be identity, and the transform is also going to be identity, and should finish. Come on, should finish. We don't have it here anymore. Okay, should finish should be never, like this. All right, so it compiles, and I'm going to copy that, and I'm going to go over here and have 10 like this. Okay, so the first one, it just generates a bunch of 0, right, because it's identity, and the second one generates a bunch of 10s. So now if we go over here and we're going to say val result, which is a timeline of ints, equals timeline 1 interleave timeline 2, and all we need is to take just 2 elements. We don't need much more, right? So if we go over here, events occurred should be 0, and if we have a list like this, it's going to be result dot forced. So now events occurred should be 2, like that. Scroll down a little bit, like this. It should be 2, and a list should be list of, it's interleave, right? So it took the 0 from the first one and the 10 from the second one. Okay, let's do this, and it should be red. Yes, it is red. Let's scroll up. It says 3 was not equal to 2. So again, there's one thing too much going on over there. In order to fix that, again, it took me quite a few days. I figured out that there is yet another by name error that is missing. So if you go to canonical unfold, this is the one in the data. It turns out that this jan, it also needs to be a by name parameter. Whoops, that's not what I wanted. Go back. All right, so we're back at this one. So this jan, it needs to be a by name parameter. Okay, and now because it is a by name parameter, then this should be a lazy val, and let's see if that was already enough. It is not enough because timeline Scala 293. Oh yeah, we also need to go to timeline and make sure that it's also like that. Okay, so now it is actually enough. Now let's do the same thing for the other version. So if you just gonna copy, what did I touch? I wanted to touch just the environment, right? So this is the canonical unfold. Let's also have another environment where we're gonna go and say, so we have 2 of them now in Gen 7, right? So this one and this one. Okay, so the canonical unfold is now fine. Now let's go and use the regular unfold. So we're gonna do unfold over here, and it's gonna be side effect 0, right? But now all of that is going to look different. So we're gonna say n sum of n arrow to the right, and it's still going to be n, right? Because we're generating the same thing. Okay, so like this, and I've got to put the parenthesis over here instead of over here, some stupid reason. All right, like this. So it's a bunch of 0, this is a bunch of 10s, but now we're using the unfold and not the canonical unfold, and it's going to fail with exactly the same error. It should say 3 was not equal to 2. Yes. Scroll down. There we go. So let's go to timeline. And let's go to unfold to the one at the bottom. Now, if you look at canonical unfold, not all jans are by name parameters. Okay, it's only this one, so only the one that has something to do with the boolean. But if you look at this unfold, if we just do this, it's going to be too much. Right, so technically what we want is we want to go over here and we want to say that inside of this option, inside of this tuple, that this event over here should also be a by name thing, and this gen should also be a by name thing. But that's not how tuples work. So what we need to do instead is we're going to wrap them in either thunks or IO. So I'm going to do this. I'm going to say that this is going to be an IO of event, and this is going to be an IO of gen. Like this. Now at this point I was so frustrated with the streams that I actually gave up trying to figure out how to make it work over here. So instead I thought that it might be actually a good idea to just inline this and just to delegate the entire thing to canonical unfold. So we're going to go to canonical unfold like this with the same seed. Okay, and we're just going to say, okay, so next is going to be take the gen, call next on gen, call get, take the second thing out, call and save run on it, right? And do the same thing for the transform, right? Transform, it will just take the first thing out, and hold on, I forgot the comma over here, and should finish should be gen, next gen, same thing, and now it just is empty, right? Cool. So let's see if it compiles. It shouldn't compile because at the top, hold up, let's just go and fix it right away. So at the top, unfold this one, it should look like this now. Okay, so everything should compile now except for the tests. All right, some mistake over here, 6, 7, 9. Let's see, what did I do wrong? It's not transform, it's transform, like this one. All right. Okay, so now the test and compile 253, like this over here. So we just need to make sure that we're wrapping everything into pure. So all of these, oops, hold up, let's go here like that. Okay, so this is going to be IO pure, and this one is also going to be IO pure, like this. What else? 234. All right, so it needs to be in io.pure of bank account, like this, and this needs to be io.pure of n+1. Okay, let's see. Cool, it's green. Now, it's not the cleanest thing. In fact, before I created this, this implementation of streams, I've never seen unfold being defined like this. I was actually surprised that I was, I kind of felt like I was the first one to do it like this, because usually if you look it up in the standard library, for example, then it actually looks the same way as as it looked before we arrived over here. Now, anyway, let's go and have a few helpers over there in timeline. So if we go to unfold, so we have the unfold and we have the canonical unfold. So the next thing that we're going to have is we're going to have a generate transform. I'm going to call it generate transform. And it's going to look the same way. So it's gen and event, and then it's going to be a seed. It's going to have a gen over here. And now it's going to have the next function, which takes that like this, but it's not an option. It's just a tuple like this and like that. Okay, so all it will do is do that. Okay, it will just call unfold with the seed, and it will just convert this function into that function. Okay, so we'll just take the thing from that. It will just take that tuple and stick into a sum, right? So generate transform will be used when we want to generate streams that never finish. Okay, and I'm going to copy that. I'm going to go over here, paste that in. By the way, it should be an inline, the same as this one at inline. Okay, so I'm going to call this one canonical generate transform, like that. So it's just gonna not have this like that. Okay, so all we need to do is we need to go over here and we need to call this canonical unfold, right? Just with the seed, we're just passing everything along, next transform, and we just need to pull this function out of our head like this. There we go. Also, it's going to be a stream that never finishes. So now we can go and we can start using them. So for example, canonical unfold, over here, Gen 5, right? So where we use the unfold, we can just instead say timeline dot generate, how did I call it? Generate transform, probably, right? Yeah, generate transform. Okay, so it's going to be generate transform like this. Found bank required. Just need to make them to wrap them into io.pure like this, and same over here, io.pure like that. And now we don't need this unfold. Okay, like that. Let's go and do the. In fact, maybe because the line gets so long, let's do this and enter over here. Let's go over there. Let's do that. It looks prettier. Okay, what we have here. This one is the canonical transform. So timeline dot canonical generate transform like that. Remove this, and let's see. That should be enough actually. Yeah, looks like it compiles, so we can remove that. Let's keep scrolling up. Same thing over here. Okay, timeline dot can gen trans. Yeah, there we go. Remove that. All right, let's keep scrolling up. This one. Oh, okay. So for this one, we don't have a helper yet. So let's go and create it. Let's go to timeline, and we're gonna have only one of them. So we're gonna have at inline final def generate. Okay, so generate event, and it's gonna be a seed, which is a by name event like this. So it just gets the function. Next, just goes from event to event. And we're gonna produce a timeline of event, and we're gonna do a can gen trans, and it's gonna be seed, it's gonna be next, whoops, it's gonna be next and identity, right? Because there's no transformation, there's no gen, there's no need to transform anything. Now before we go and use it, let's also have the last one. So we're gonna have at inline final def generate same, it's gonna be event with a seed. Just over here, it produces a timeline of event like this, and it just calls generate with a seed with identity. Okay, like this. So now we can go to our tests and we can use them. Okay, so over here we can just say timeline dot generate. I believe that should be enough, like that. Over here as well. So we have the ascending over here, so now we can just say timeline dot generate. Are we generating the same? Oh no, so this was the ascending one. In fact, we don't even need the ascending one anymore. What's the point of having it? Let's just throw it out. Just throw this out. And gen 1 is over there, so we can just say timeline dot generate same, and we don't need this. And what else? Gen 0, we can just copy it from here, right? So it's just that, just a bunch of 0, 0, and 0. And I believe now actually it doesn't really matter if you use a val or if you use a def, because we're calling generate same in both of the cases. So we can just remove this 1 4, so it's always going to be 1. Okay, so it doesn't matter now if it's a val or if it's a def. And what did I do wrong? It's probably the other way around. I removed the 4. I should have removed the 1. Yes. All right. So that's going to be a 4, and that's also going to be a 4. Yeah, exactly. So there was a 4. There was a 4. Okay. So it's 4 in both cases. It doesn't matter if it's a def or if it's a val. Now let's clean up a few things. So basically now Gen 0 and Gen 1, they look exactly the same. Hold up, Gen 0 and Gen 1 exactly. So we can just throw Gen 1 out. Right, hold up, we're generating a bunch of 0. Yeah, we're generating a bunch of 0. So we don't need Gen 1. We have Gen 3. Okay, so this is going to be Gen 2 now. This is going to be Gen, okay, let's call it Gen 0. Let's call this one Gen 1. It calls generate. Now we're going to have Gen 2. It calls canonical generate transform. Gen 5, which is now going to be 3. So we have 2 and 3. So this one actually transforms something. It has 2 environments where it calls the other generate transform. So it calls one of them. It calls this the second one of them. And now we have Gen, which is it, 4, I guess? Yes, Gen 4. So it's going to be Gen 4, which calls canonical unfold, and also another, okay, again, canonical unfold, and the regular unfold as well. Yes, exactly. That's all we need. And this one, the 7th one, which is going to be 5 now, I guess. It's the one that tests the interleave, and that's it. Okay, cool. The next thing that we're going to do is actually going to be super fun. We're going to go to the package object of the homegrown collections over here, and we're going to add an infix notation for our folds. So we're going to have implicit final class, so basically a tiny DSL. So I'm going to say infix notation for any from HCC. It's going to be for any because this any is going to be this gen, right? So this is going to be the seed that we're going to call everything on. Okay, so we're just going to say at inline final def unfold event like this. So it's going to take the gen, it's going to take the transform, it's going to take gen event like this. It's going to take should finish like that. Gen boolean produces a timeline of event, and it just delegates to timeline.canonical unfold seed next transform should finish like this. Let's see if I made any typos. Of course I did. It's called next over here, and it's called timeline like this. Notice that I called it unfold even though we're calling canonical unfold, and the reason being is that we're going to overload unfold in this case, because in the timeline we couldn't do it because in the timeline we had a current function and they all start like this. We have like a bunch of functions, they all start with this, but in this case this thing is in the class, and so we can have two functions that are both called unfold. But before we do that, let's go and actually use it. So let's go, let's see it from the bottom. Okay, so let's see. Over here we're doing canonical unfold. So now we can actually use this one, right? So this is the one. I'm going to put it on the right like that. Okay, so over here. So we can now just say, instead of saying timeline.canonical unfold side effect 0, we can just say side effect 0 dot unfold. Okay, and just open the brace like this. Okay, so instead of this line we can do this line like this. Okay, let's see if it works. And it looks like it does. It says done compiling. Okay, so now we can do the same thing over here like this, but it's a 10 now, so it's just shorter. All right, so it's a 10 now. All right, over here, so over here we're using the other one. Okay, so before we fix that one, we need to have another overload. We're gonna go over here, and I'm just gonna duplicate that, bring it down like this. Okay, so now it's gonna produce a timeline of event just by calling timeline unfold seed and next. So all it needs is, in fact, we can go over here, we can go to unfold. Let me create more space. We can just take this entire function like this and put it in here, right? Because it's the same function. Okay, so now we can go into our tests. Whoops, what just happened? What just happened? All right, so we can go into our test. Let me create more space like this. So we can go over here. Instead of saying timeline.unfold side effect, we can say side effect 0.unfold like that. So we can just remove this. And over here, we can remove that. Okay, so it doesn't matter if you're calling canonical unfold or if you're calling just the unfold, the syntax look the same, right? So in this one, Control D, it's going to be the same, but this one wants 3 functions, and this one wants only one function. Now, because I feel in the mood, we're also going to go over here, and also have at inline final def, let's just call it IO, which is going to take the Jan actually, and produce an IO of gen, and all it will do, it will say IO pure of seed like this. All right, not sure why I did that. That's kind of silly. We already have the gen like this, and it's called inline like this. Okay, now because we have this little thingy over there, we can just go over here and instead of saying IO pure of n like that, I can just say n.io. It's just way shorter. Okay, so let's go and see what else we can fix. So we started at the bottom, so we fixed these two. We can go up over here, so we can just do side effect 0.unfold like that dot unfold. We can go over here and we can just say bank account of n.io, and over here n+1 .io like this. Let's keep going. Okay, so over here we can just do that, remove the whole thing, and just say unfold like this. What else? Same thing over here. Paste dot unfold like that. What else? Okay, so these ones are already for generate transform, and for them we need a few more over here. So we're gonna go over there, and I'm gonna call one at inline def timeline transform produces an event, and it looks like this, that it takes this function like that, but the one without the option, just like this, like that, still produces a timeline of event, and it equals timeline dot generate generates the first time I would call it transform with seed and was the next. Let's see. Let's actually do the other one as well. So I'm gonna copy that. I'm gonna paste it over here. It's gonna take in these two functions like that, and it's just gonna call canonical generate transform with a seed next and transform. We don't need this comma over there. All right, canonical generate transform. Okay, so the same thing as over here. So one unfold calls the canonical one, the other one calls the regular one. The same thing over here. One timeline transform calls the regular one, the other timeline transform calls the canonical one. And in fact, why am I sorting them like this? Let's go and move this down like that, because I wanna maintain the same order. All right, so before we continue, let's also add all of them. Okay, so I'm gonna have at inline def just timeline. I'm gonna call it just timeline gen, and it will just call timeline dot generate same with a seed. And also I'm gonna have, what's happening here? Where is this D coming from all of a sudden? Okay, and another timeline is gonna take the function which is gonna take the gen and produce the gen. It's going to be a timeline of gen, and now we're just going to delegate timeline dot generate seed and next, like this. Okay, so same thing again. All right. Okay, so we have IO. We have two versions of timeline, two versions of timeline transform, and two versions of unfold. So now we should be able to fix all of them. So in this case, we have the generate transform. So I believe I called it timeline transform, right? Yes, timeline transform. So we can go over here, say side effect 0, like that, dot timeline transform. And by the way, we also have .io over here, like this, and .io over here, like that. Okay, so we can do the same thing over here, side effect 0, dot transform, timeline transform, like this. Okay, over here we have side effect 0 of timeline transform, timeline transform, like this. In fact, in this case, we're not transforming anything. What's the point of calling this? Let's remove this one. Right, so now let's rename this one to 2, this one to 3, this one to 4, and I believe this is the last one, right? Okay, so let's go up. Okay, so we have the generate one, so it's gen 2. Okay, so gen 1 over here. So we're saying timeline then generate, and all we need to do is we need to go here and say dot generate transform, no, it's called timeline transform now. Timeline transform. Timeline transform. What did I do wrong? Hold up. Timeline transform. There's one version like this, one version like this. Oh, now it needs the, but it's the same, isn't it? Identity. Okay, in this case, because we're not transforming anything, let's just call timeline, right? Because otherwise we already have a test for this, right? So in this case, we have timeline transform. Yeah, so we're testing the transform over here. In this case, we're doing just timeline. So look, it looks really cool, right? So side effect 0, timeline plus 1. Over here, why is this one collapsed? What is that? That's, we're generating the same one. So we can just do side effect 0, and then we can say timeline, right? So we're just converting a 0 into a timeline. Let's actually copy that and paste it over here, like this. And I believe that these are actually all of them. And so the last thing that we're going to do is we're going to go to playground, where we have our example. And then I'm gonna run now actually. So I'm gonna have run main homegrown collections playground. So it asks me for my name, which is Vlad. Full name is Vladislav. Vladislav. Okay, so what we can do now is we can go over here, we can just throw all of them out. So instead of having this val for questions, right, we can just now take this, put it over here, and just say timeline. Let's see. I'm going to press enter a bunch of times. Hold up. The same thing over here, alternative questions, right? Let's just take this and convert it into a timeline. The read, what is that? The read is just this. Convert it into a timeline. Paste. Timeline, like this. So now we don't need any of that. And our example is super small now, like this. Let's run it again. What's your name? Vlad. What's your full name? Vladislav. Vlad. Vladislav, like this. All right, so that's pretty much all I have for you today. Let's run the test real quick before we go and commit that. All right, it looks like it's green. Let's do that. Let's open another one. Let's add everything. Let's commit -am, and that's going to be video 33, and I'm going to call it streams, and I'm going to call it unfold like this. All right, let's just go and push. Like this. It looks like it's been pushed. Yes, it's pushed. Let's go into here. Let's open my browser. Let's click on commits, which is 51 now. Let's see what we did. Streams unfold. All right. So in the playground, oh yes, we did the renaming. We did the renaming. We improved the playground over here, so we just removed all of these vals. We went to timeline, and okay, there's a bunch of renamings over there. We added a bunch of these, a bunch of factories, so now you know how to generate streams. Okay, that's just renaming. Okay, over here, unfold and canonical unfold are in data, right? So we didn't need the other overloads. We're just using these ones. What else? Infix notation. Oh yeah, we renamed the identity law. We had added a bunch of tests. In fact, in the end, it wasn't a bunch. It was just 4. Interesting, just 4. Okay, and the rest is just the renamings. All right, and that's all I got for you today. There will be only one more video about streams, and don't forget to like this video if you did, subscribe if you want to improve the developer inside you. If you find my videos valuable, consider supporting me on Patreon, but most importantly, take care.